being here in the morning to India. Thank you very much on behalf of Patil College of Engineering, Akurdi, Pune, sir. Your topic is opportunities and challenges of AI in autonomous systems, self-driving cars, IoT, and intelligent systems. Abhinit Patil, sir, is a 18-year-old tech leader who has co-founded Intelli, a software training company, and Brainzaa, a software development company. Abhinit, sir, is currently working enterprise and bring value to society as a whole. He has consulted companies such as Walmart, Wealth Simple, and is an alumni of the Knowledge Society. He began his journey when he was 16 years. However, his love for tech has been there since a young age. Ever since then, Abhinit sir has on meetups and completed many projects with his team. Abhinit sir has technology and business, and he has continuously strived to create a positive impact on people around the world and contribute to the growth and progress of humanity. Thank you very much, sir, and we are eager to listen from you. Over to you, Abhinit Patil, sir.
Introduction to me and all the speakers that are going to be joining today. And they've taken an amazing initiative for organizing this amazing webinar series and inviting speakers from all over the world to present and give their thoughts and perspectives on the technologies that we will be encountering in the near future. So today's topic is artificial intelligence, and my focus is around the autonomous systems. So how does artificial intelligence shape autonomous systems? What does it mean to have an autonomous system? And so how I like to think about autonomous systems, and I give this example whenever I talk about this, is think about a system as a way elements collaborate together. So you have each part working together to form this one big group. So until now, we've had technology, artificial intelligence, robots working individually, being very specialized. Now, the key in all this progress, so if you were there 3 weeks ago, I also gave a talk on Industry 4.0. At that time, my pure focus was on hyperautomation and how we can have empowered edge. And that was the focus of my presentation. But Industry 4.0 is an overarching concept. It's a term that encompasses all of these trends. And so today, my focus will be around autonomous things and how they relate with each and every one of these. So how autonomous things relates with distributed cloud, how it relates with, say, how hyperautomation. With artificial intelligence, the first thing we need to do is figure out what it actually means. What is artificial intelligence? A lot of people ask this question. Even a lot of us, we still are looking into ways on how we can get involved with AI. And so with artificial intelligence, I'd like to use this field of study that gives computers the ability to learn without being explicitly programmed. And this is a quote used said by Arthur Samuel, and he's one of the first few people who actually worked in this space. He's the person who coined the term machine learning in 1959, so way far back, like 70, 80 years back. And he built the first checkers playing program, so a computer program that a human can play checkers with. And so he's one of the most early computing experts that was very, very prominent in the computing age. And so think about artificial intelligence as a technology that can enable it can enable non-living items to think like living things and behave like living things. And so when we look at AI, it's a broad term. It encompasses many, many things and a variety of technologies that fall under AI. So artificial intelligence, just in a nutshell, would be crafted intelligent behavior by machines. And in that case, in AI, you have these various streams that we've heard of, like machine learning, natural language processing, robotics, computer vision, and all of these things that fall under AI. With machine learning, you're dealing with a tremendous amount of data that is labeled and processed heavily, and that which can be further enhanced using deep learning. You can analyze that data further and further using techniques in deep learning, which essentially requires you to create neural networks. Some of the things that we're doing with some of our clients is we're enabling them to use big data and processing that data to find trends and insights in their business processes. So how can we boost businesses processes and bring them to the next level? We have natural language processing, which essentially deals with how basically our machines can imitate human speech and speech to text relation, and how can we relate speech to speech connection. And that's what the domain of natural language processing goes under. Then we have vision, computer vision, that has all the things to do with image detection. You have recognition, you have surveillance, you have all those things that fall under computer vision. How can we detect and identify, learn from our surroundings? And that is what will form the biggest innovations in AI. Computer vision is a fundamental part of things like self-driving cars, which I'll be discussing later in the session today. And so, but the common thing with all of these technologies is that there's three things. You need data. You need tremendous amount of data. You need to get that data. Then you need to understand the data. So the machine needs to understand the data using the various algorithms. And based on the data, whatever the insights that it's able to extract, whatever is the trends it's able to extract, it's able to make a decision. And that is what would form what we call AI, artificial intelligence. So how do we get the data? So where does data science, all that come under? So a lot of the data is available to us. It's online. You have websites like Kaggle, which provides tremendous amounts of databases and all those access to a variety of labeled data existing in the market already. Many companies have their own databases. So even Facebook spends heavily on just maintaining its data, extracting information from the variety of searches we all do on our phones. And the thing is, AI is already out in our lives. It's something that's almost inevitable. It's there in our lives. We're dealing with it every single day. If you look at your phone, there's constantly there's algorithm running in the back that's extracting all the data from what we're searching, from who we're texting, the type of behavior we're exhibiting online. And that's why if you ever have a particular search on, let's say on Google search, you say, I want to learn how to code, for example, then you will automatically see sponsored ads on Facebook, which show ads related to programming, courses, university degrees, and all that stuff. So that is all because of. So when you have data, you need to first, you can't just feed it any data. It needs to be labeled so the machine can identify it. That this involves crawling and finding data, labeling it. So a lot of work goes into that as well. So a fundamental part of AI is having proper data, and that is where one of the challenges could also be come under. And I'll speak about that later in the session today, but how just maintaining the data and processing the data before it is actually used for training, it needs to be first clean. It needs to be first processed, and you need laptops which can leverage supercomputers in a server farm out in, say, the desert. And then we also have expertise that's being built up. We have an entire community that's actively working on machine learning. They're developing algorithms. There's tremendous research going into this. And so now is one of the best times for any company to jump into this AI field, or anyone to start building new products related to AI data science. So the fundamental part of today was, how does AI relate to autonomous systems? What does autonomy mean? What does automation mean? So the biggest misconception we all have is automation is the same as autonomy. It's a big misconception. And this is because we already have automation. We have tremendous amount of automation that exists in factories. You have cars that are being manufactured by robots. But with automation, a definition by Merriam-Webster is that automation is the automatically controlled operation of an apparatus, process, or system by mechanical or electronic devices that take place of a human labor. So yes, they do replace manual labor by humans, which is often repetitive and very narrow focused. So automation is not self-directed. It requires command and control. So it does require us humans to be there and write down scripts, for example, that it will execute, and repeatedly do that without any changes. So the key thing here is a system can be automated without being autonomous. And that is a key distinction we all have to make. So if you were there in my Industry 4.0 talk just 3 weeks ago, I discussed how we went from Industry 1.0 to 2.0, 3.1, so what? So 1.0 started with having steam-powered engines, electricity. That's when the first industrial revolution came around. And that's when we found this new thing, that electricity revolutionized how we produce things. how quickly we produce, and how quickly we get them across different areas. Then we had Industry 2.0 when the production line was brought into use by Henry Ford with the Model T. At that time, it was basically humans working in factories, but very specialized on a specific task. And then over time, people were like, okay, what if we replace those humans with machines that can just do the manual labor and get things done faster? At that time, people also had the question of whether or not, automation, robots are going to take over jobs. And they did, but it also opened up new jobs for many, many people. And so that was when automation occurred. So around like 1970s, 80s, that's when robots started getting into factories. However, they are not intelligent robots, and that is what essentially autonomous aims to do. So with automation, there are machines that are super good at doing repetitive and narrow focused tasks, which is of course instructed by humans. So the question is then, what are autonomous systems? Autonomy is the ability of a system to achieve goals while operating independently of external control. So what this is trying to say is, you're not telling the robot at every moment that they need to do this, or you don't have a preset of direction that they always have to follow and they cannot go outside of that box. Autonomy, it requires self-directedness. It needs self-sufficiency. So usually these autonomous robots or autonomous systems they can basically deal with unexpected situations. They can deal with things that they're not used to. They can make decisions. The three key things in autonomous systems is, one, it's able to sense. So it's able to interact with its surroundings. It's able to gain data from surroundings. It's able to process its surrounding and figure out, okay, where it is. It's able to, for example, find out that it's located, like localization. It can find its distance relative to another object. It's able to sense your surroundings. Based on the sensing, the data it captured, it's able to run them through algorithms to understand a bunch of elements, and they're able to function together. And that is able to produce a capability required to meet a need. So think about a bunch of robots working together, simulating and collaborating like humans would. And that is what when an autonomous system is created. Yeah. So autonomous is the next transformational wave. We know that, we've seen it, and it's instant and inevitable. I mentioned already how we started with mechanized systems, which were powered by steam and electricity. So a lot to do with manual operation. Then we had this whole software computer age it's still going on now. We had automated systems. They were powered by software and hardware. We had tremendous advancements in computing. We advanced at the pace of, if you've heard the Moore's law, which doubled every 2 years, essentially computing power. At one point, it became obsolete. Around 2015, they released that the annual growth of computing power was only 3% on a laptop. However, we came across this new concept of cloud computing early 2000s, which basically gave us access to infinite computer power at our laptops, except it's not on our laptop, it's somewhere else. We're getting an access to that power from a server farm out somewhere in the world. And then now we have this much power, we have this automation. However, we're trying to deal with how can we add intelligence to that system? How can we make that system sufficient by itself? And that is where we get autonomous system. And at the center of which will be AI. Think of AI like the new next step revolution, like the internet was. Internet was an enabling technology for cloud computing, for programming, for all those things. It was an enabling technology. And now AI will also be an enabling technology for many others. Want it to be? They're not at a superhuman intelligence level yet. However, the possibility is there. And so with robotics, the key technologies that play in robotics is simultaneous localization and mapping. So it's called SLAM. Essentially deals with how a robot can actively look around its surrounding, detect where it is, and localize itself. And then using that, it's able to navigate its surrounding. Robot perception, planning, simulation, all these things fall under intelligent systems. And so the opportunities that we have with this is we have intelligent manufacturing. So what does intelligent manufacturing mean? So with intelligent manufacturing, you have essentially what the factories we have now, but each machine or each part is basically communicating with each other through a network. So you can think of having a cloud network here, which within that premise, it's this machine is able to communicate with this machine and it's able to say, okay, successfully done, tested well, item is working, a part is functional, and then it moves on. If say at over this point, it detects that the item is not fitted properly, it's able to relay that to a cloud network or a network over there that's able to provide alerts and insights on what went wrong in the production process. That's where the intelligence comes. That's when this machine, if it detects an error, it's able to indicate the next process to stop or wait until approval. And that's when we put in the intelligence in the manufacturing. A lot of which we're starting to see, but it still needs, and it still has tremendous potential for improvement. Then we think about everyday home robots. So we have a vacuum robot in our house, which is the Roomba robot. It basically operates on its own. It has limited intelligence and it has limited autonomy, we can call it, and it's able to navigate its surrounding using some of the technologies I mentioned here, like localization. It's able to get around the house and vacuum. However, it's not at a point where we can give it other tasks, like go and cook food for me or something, because it's very, very special. It's very, very narrow. And that is actually one of the challenges I discussed later in the session today. So yes, we have intelligent robots. There's limited intelligence. The opportunity is, can we develop robots that can do multiple tasks that are general AI? They're generally capable of doing various tasks. Then we can think about AI robotics in the context of customer service or support. So basically, if you head down into any stores, are there any robots to greet you, for example, to speed up the billing process? So yes, we do have self-checkout. They're not necessarily intelligent robots at that place. And so how can those robots be designed to better serve the customers? How can we use these robots to improve our customer journey, say in a business, from a business standpoint? And that is something we're starting to work on that. We're looking into that domain as well, as how can we use our expertise and try to put together better customer journeys. And a key fundamental aspect in retail stores is the physical interaction. So can we use a robot to improve the physical interaction with our customer that's walking in? Things like that. And then we have a big field that's coming up now is nanobots. So with nanobots, you have these intelligent robots, mini robots at the scale of nanometers, very, very small. You cannot see them with your eyes. But these bots are deployed in your body, and essentially they can be used. They're not there yet, but they will be sometime in the future, and they can be used to specifically target cells. So if you, for example, cancer cells, you can use these nanobots to work together and identify cancer spots before they become a big deal. And then you can do precision medicine, for example, to basically target that specific cell and destroy it. I believe it's around level 2 at the moment. There's 4 levels. Level 1 is you have research. Level 2, you have a working prototype rather, but it's not at a place where it can be even trialed upon and then delivered. So as we move through phase 2, phase 3, and phase 4, we'll eventually get to systems that can do a lot of these things for us, like surgery as well. So a lot of people also have a misconception as, do we have robots now or not? Although we don't see them around us every single day, they have been there for a long time. The key distinction is we have automated non-intelligent bots, which exist already. However, autonomous and intelligent robots, there's very few of them, or those robots are not really as intelligent as they should have. And so with automated non-intelligent bots, we have those robots that are programmed for repetitive work, very, very narrow focused and super specialized. Because they're super specialized, they can get really good at the work. They can do things better than us, they can do it faster, and they can save a lot more money. And that is why a lot of manufacturing replaced manual labor with robots. They're automated, things can be done fast, but not intelligent. Then we have autonomous, which people are working on now. How can we bring these robots into our lives? So building, cars, self-driving cars, which can navigate the traffic and remove the need for a driver. There's 5 things with autonomous and intelligent robots. So 1, it should have decision making. So the ability to make some sort of decision. It's able to take an action, for example. abstraction. So your robot in a real life situation, you'll be engaging with a variety of things. You'll be bombarded with thousands or millions of things that are coming at you. Humans are extremely good at that. We've evolved over time to handle multitasking. We're able to handle so many distractions around us. And we're able to also extract key information that will help us live our lives. And that is something that's a really big challenge in training these. They should have some response to it. Otherwise, it's useless if they can just sit around and just do nothing. So reaction is something that has to be there, and there should be a way that machine can learn. So how can it get better? When you start with an intelligent robot that, early on with the algorithms, they're not so efficient. They have around, 60% efficiency, or sorry, accuracy. And that depends on situation, but usually you start with lower accuracy. And your goal is you want to get towards as close to as 100% as possible. And so with AI, that potential is there. And if it's able to learn from previous experience, that's where the whole opportunity lies. It's able to learn from previous experience and get over time. So the more you train it, the better it gets. And I'd like to mention also a key field of AI, which is specifically to this, it has a reinforcement learning. So basically, it's modeled after how a baby would learn from its surroundings. So a baby basically is born. They see, for example, you're a baby in a room, and then there's a fireplace. And then as a baby, you don't know when you're born that the fire is harmful to us. And so the baby sees the fire and it moves towards it, right? And then as it moves to touch it, it gets its hand burned. And so at that point, your brain registers, okay, that fire is harmful, it hurt me. And so your brain processes that as a threat. And that is how a reinforcement algorithm or analogy of that algorithm would work. And then that AI offers it the opportunity to learn from previous experience. So based on that, it's able to have some intuition to it.